So here we are going to talk about the TCP connection management. So let's start. So first, in the first slide, you can see there's a dropped call problem. Like uh, they are giving the 50-digit Wi-Fi password and they are just writing it down, and some numbers are being missed. So in the receiver end, there is a problem being created. So when we create a logical illusion of a pipe, so it is a connection oriented as we know or told before. So it even operates on IP, which is connectionless. So this is a logical but not a physical relationship. So here you can see like there's a start and an end, and it has a TCP layer as a connection oriented one. And here the IP, it handles the delivery and it is the best effort. And the TCP here, it handles the state. So as we said before, it is much more reliable. So if a segment is lost or it is being corrupted, it is retransmitted. Unlike the TCP, IP is unaware of this kind of retransmission. So these are the primitives. So here there is a receiver and a client. So in the receiver, there's a server. Sorry, it's a server and a client. So in the server, it has a state of listen and passive open. And the client, it has like a state of closed or connect active open. So in the first one, it is waiting for the incoming link, and the second one, it is initiating the call. So here it is the TCP connectionless phases. So it has three types of things. So it has the setup, the data, and the close. So in the setup, it has connection establishment. So where we use the words such as sync acknowledgements and acknowledgements, and then the data is being transferred, like data segments are being transferred, and then we have the connection termination process. Like for that, we use fin acknowledgement, fin, and again acknowledgement. So first, in the first step, like the client sends a sync message. It consists of the sequence, the number, and the MSS. So that is 1460 bytes. So it is a three-way handshake process, and it begins here. And then in the second step, the receiver, it replies to that with a simplest acknowledgement message. So it confirms that the client sync by incrementing it by one. And then the final is the acknowledgement. So here it is the acknowledgement segments do not consume the sequence numbers. So here it establishes just the state, and it is very vulnerable. Like it is spoofed IP, and it is given to the ICB table, which is the memory, and then it gives to the synchronization plus the acknowledgement, the data transfer, and the piggybacking. So it is nothing but the server uh, consists of the it is given to the piggybacking, which means the acknowledgement of the incoming data. It writes inside the outgoing data segment to save the bandwidth. So here, as I said before, it is a three-step process, and the communication begins and ends there. So this is the controlling flow. So TCP continuously adjusts the speed to avoid overwhelming of the receiver. So first it started buffering, and then it used the push and pull flags and an urgent pointer where it reads this out of the order or immediately. And this is how the termination is done. Like I have explained before, it consumes zero sequence at the end. And this is the half close or reset, just a figure. And then this is the attack or normal. So this is also, as I said before, it is represented in a picture format. And this is the summary, like first half close and reset. Sometimes one side stops sending, but still the other side receives, and that's called as half close. And the connection, it can suddenly stop, that's called as the reset. So on a security mode, there is also attacks like sync plus flood, which misuses this handshake process. So that's TCP connection management for you from starting to ending the communication. So let's see in the next video. Thank you for watching. So these are some of the references and you can refer it also.